Hi, Year 11, this is Mr. Lim, and this is the fourth video on aqueous solutions, and it's on ionic equations. Okay, so we're going to go through a couple of examples and just try it out. Okay, so writing ionic equations, a couple of things you need to know about ionic equations is that, right, it's just like a normal equation except a couple of things are different. You don't show spectator ions, which are ions that don't do anything, and you show ions in their split form, or aqueous solutions in their split form. Okay, so let's go through. We have the four different states. We have solids, liquids, and gases, right? And all of these will stay the same. All right, but then we have the AQs, but even AQs can come under a couple of things. Those that fully ionize or dissociate, and those that only partially ionize. Okay, if it fully ionizes, we split them. And if it only partially ionizes, we keep them together. Okay, so let's go through and let's work out what to do with this particular equation to turn it into an ionic equation. Okay, so first of all, we have a look at the first state, that's AQ. This is HNO3, which is a nitric acid, which is a strong acid, which means it fully ionizes, which means it splits apart. Okay, so we got to split that one. Okay, we have a look at the next one. Solid, okay, solid, we don't split apart, so we keep it as one thing. Liquid, for the water, again, we keep it as one thing. Gas, we keep it as one thing. Okay, so those solid, liquid, gases we keep as one, so they will stay as the same thing. Then finally we have calcium nitrate. Now calcium nitrate and all ionic substances effectively fully ionize even if they're insoluble, right? So this means that we're going to split that into two things. Okay, so what does that then look like? So you have H plus NO3, 1 minus, aqueous, both of these AQs, right? Plus CaCO3, solid, plus, oh no, there are more pluses. Okay, so those are our reactants. Now we go to our products, plus H2O, plus CO2 gas, plus Ca bracket NO, no brackets, because these are now ions, we're going to split them apart. This is Ca2 plus, aqueous, plus NO3, 1 minus, aqueous. Okay, so that's what we've got there. That's AQ. And so we look at this equation and we think, okay, is there anything that's the same on both sides? Okay, there is one thing that's the same on both sides. It is the NO3. Okay, they're exactly the same. And I haven't balanced the equation, but that wouldn't even matter either. So, but as long as it is the same on both sides, that means we can remove it because it's a spectator ion. Spectator ion. Okay, which means it just spectates, it doesn't do anything. So you get rid of it. A little bit plus as well. And you get rid of this one. And you now don't need it. No, it's a spectator ion. All right. And therefore, that's the final equation that we have. Okay. We have H plus CaCO3 solid goes to H2O plus CO2 plus Ca2 plus aqueous. Right. One more thing. What do you think we need to do? To balance the equation. Put a 2 there, and that's done. All right. So you got to remember, solid, liquids, and gases, they stay the same. Aqueuses, if it fully ionizes, you split. If it partially ionizes, you keep it together. Let's have a look at the next. Next, ethanoic acid plus sodium hydroxide. You really should be able to pick out what actually happens here. This will form water and a salt, which will be NaCH3COO minus aqueous. Right, that's your equation. So now let's have a think. AQ. Now, this is a weak acid. If this is a weak acid, that means that this thing will not fully ionize, and therefore this stays together. Stays together. Sodium hydroxide is a strong acid, strong base, sorry, and therefore that will split. This is a liquid, so it will stay together. And this is an ionic substance, so that will also split. Okay, so now let's have a look at what you end up with. You end up with CH3COOH plus Na plus AQ plus OH minus AQ goes to water, liquid, plus Na plus AQ and CH3COO minus AQ. Is there anything that's on both sides? Yes, there is. It's the Na plus here, right? So we got to get rid of that and get rid of that. And that's our equation. Ethanoic acid, as a weak acid, stays in one thing, as AQ even, plus your hydroxide ions goes to water and ethanoate ions. Okay, that's the next one. Right, here's the last one. Okay, sulfuric acid, which is H2SO4. Is sulfuric acid a strong or weak acid? It is a strong acid. Does that mean we should split it up? Does it fully ionize or does it only partially ionize? It fully ionizes, which means we need to split it. Right. Lead carbonate is PbCO3, and you really need to memorize all of your ions and their formulas so that you can just kind of work out immediately what that is. Then this is lead carbonate solid. So you've got to read the question and make sure that you're writing down the appropriate state. What does it form? Acid plus a carbonate makes carbon dioxide plus water plus salt, which is PbSO4. And if you've got your data sheet there with you, you'll notice that PbSO4 is an insoluble substance. All right, so that one splits. What about this one? It's a solid, it stays together. This is a gas, it stays together. This is a liquid, it stays together. This is a solid, it stays together. Right? So, how does this ionic equation look then? Well, then you've got to split this apart. H plus AQ plus SO4 2 minus AQ. Right? Plus, and we keep that one together, so PbCO3 solid goes to CO2 gas plus H2O liquid and PbSO4 solid. Okay, so how is this actually different from the original equation? All right, the only thing different is here, where that is shown as two individual ions. All right, one more thing, got to balance it, put something there, and that's it. Right, so that's Ionic equations, solid, liquids, gases you keep together. Aqueouses you split if it is fully ionizing, and then you remove anything that's on both sides of the equation, and that stays the same. All right. Now let's have a look at observations. So this thing over here is in your data sheet. All right. This is that thing. This is that thing, and that is that thing. All right, that makes sense. That's why I put arrows there. So we're going to have a look at how to use that and how to work out stuff is what color. Okay, so in general, you have a couple of things. You have to look up what color aqueous stuff is, what color solid stuff is, and what color your halogen waters are. Okay, and we'll go through each of an example for each of those, right? Okay, so hydrochloric acid solution, so HClAQ plus solid magnesium carbonate, so MgCO3 solid. Right, those are your two reactants. What does it turn into? It turns into MgCl2 plus H2O liquid plus CO2 gas. MgCl, that using your solubility table, that is soluble. Right. So also something else with observations, you must show both reactants and products what they look like. Okay, so let's have a look. we have to identify the color of each of these. So, first one being an aqueous, we have to look at its component ions. Okay, its component ions, H plus and Cl minus. We look at the colored ions in aqueous solution, which is at the bottom of the page, and we look here, H plus isn't there, Cl minus isn't there, and if it's not there or there in those two tables, then this is a clear, colorless solution. Okay, so that's a clear colorless solution. Solids here, right? Different rule. So we're looking for magnesium carbonate. The first place we look is not there. The first place we look is up here, which is at the top part there. And we say, okay, well, is magnesium carbonate in that list of ionic solids? And we say, no, it's not. Okay. So the second place we look is down here. And we look at the ions that compose magnesium carbonate. Magnesium is not here, carbonate is not there. And if they're neither here nor here, then the solid will be white. White solid. Okay? So a clear colorless solution is added to a white solid to form, so now we go back to the products. This is an aqueous. Remember aqueous, where do we look? We look at this portion down here, here and here. And we see that magnesium is not there, nor is chlorine. So this is a clear colorless solution. And this is our liquid. All right, so liquid, we know water is a clear colorless solution as well. So saying that these two things are clear colorless solutions because they're both at the same thing, right? You don't have to say it twice. And the carbon dioxide is a colorless, odorless gas. Odorless gas. Okay, now it's a colorless, odorless gas which is produced off a solid which is in a solution. So this will also form bubbles. So you can say it's bubbles of a clear colorless gas. Colorless, odorless gas. Right. So this one is a clear colorless solution is added to a white solid to form a clear colorless solution, and a colorless, odorless gas in the form of bubbles appear. Right? So we're showing both reactants and products when we write out our description. Let's have a look at the next one. Lead 2 nitrate and nickel iodide. So let's write out the formula. Lead 2 nitrate, that's PbNO32, right? Plus nickel iodide, NiI2. These are both AQs. Because why? Because they're solutions, right? And so we say, okay, what do we do now? All right, so we have to find out what, first of all, is the reaction. This is a precipitation reaction, and using the rules that we learned about precipitation reactions in the last video, you're going to work out that it's nickel nitrate, AQ, and lead iodide, solid. Okay? So now we have a look at what's what. Here we have an AQ, so you've got to look at the positive ion, that's down here. Positive ion is there, negative ion is there, lead or nitrate are both not there. So this is a clear colorless solution. Colorless solution. Okay? Next, again it's an aqueous, so we're looking over here, and we say, ooh, look, nickel is there, it is a green color. Iodide is nothing, so this is a green solution. Alright, so you got a green solution and a clear colorless solution, and they're mixed together. It's going to form a, let's have a look, this is another aqueous solution, so we're looking back down here again, and again it's nickel, and again it's green, so this is going to be a green solution. And this is a solid now, so it's something different. So where do we look for solids? Okay, so first of all, the first place we look is at the top over here, and we say lead iodide. Is it there? Yes, it is, right here. Okay, and that is a yellow solid. Okay, so your final answer is a clear colorless solution is added to a green solution to form a green solution with a yellow solid inside it, or yellow solid is precipitated out. Okay, one other thing about observations is that you do not say what the chemical is. You do not say what the chemical is, you just say what it looks like. Alright, so you don't say the lead nitrate is clear colorless and the nickel iodide is green. You just say a clear colorless solution and a green solution are mixed together. Right? Lastly, chlorine water. Okay, so this is our halogen water. Halogen water is the color of halogens in aqueous solutions. Right? And that's in the middle portion of it. And chlorine water, which is this one, which is pale yellow. Okay, so this is pale yellow. Ethene gas, ethene and all of the hydrocarbons are effectively a colorless, odorless gas. All right, and what is the reaction that's going to occur? Cl2AQ. Right, plus ethene, which is C2H4 gas. What type of reaction is this? This is organic. It's a addition reaction. C2H4Cl2, that's a gas, and therefore that's also going to be a colorless, odorless gas. Colorless, odorless gas. Okay, so the reaction is a pale yellow solution has a colorless, odorless gas bubble through it, and a colorless, odorless gas is produced. And if you think about it, the Cl2 is consumed in the reaction. And if it's consumed in the reaction, you're not going to see it anymore. So therefore, it also forms a clear, colorless solution. Okay, so there's a couple of examples of how to use the data sheet for ionic equations and observations. Okay, if you want practice, you come ask me and I'll give you some sets to do, okay? All right, that's all.